Hi, hi everyone. We are Group VSB Plus, and this is our final presentation. Our website project is designed to help the student to organize and arrange their course schedule wisely to allow a further view of their academic year for a better plan and graduate smoothly. And why we are doing it is to help the student to avoid taking the unnecessary courses that provide a better time management. Our project users are the students who may have problems with course registration requirements, as to guide them in building up the course schedule. As well, it can give assistance for the advisor to do the explanation of course question with the student easily.
This is our index page. Just start with our Let's Go button. We come to login page. You can log in with student ID or password, or you can log as guest, or you can go to our admin section to modify the course database as admin, or manage the course history as students. And there are some user notes about our web page. And let's try to go to our log as guest. Just come to course list data page, and you can search a course you like, and show the select course information on the right side, and also you can set the year filters and find the course that you are interested. Also, let's go back to the login page, and let's go to admin section to manage the database. So let's try logging as admin. And we'll come to the course list page, so you can add a course or edit a course, delete course. Let's try to add one test course. Test, add a course. Now we can search the course in our database. So we just add the course that shows the course that we added, and we can edit the course to change course number to 222. Now we can find the course or just edit. Also, we can delete the course if we want. Also, we check it, so nothing's found out because we just delete and just log out. If we are student, how to manage our course history. And let's go to our course history list. Also have the same function like the admin. You can add the recording or edit and delete if you want. So let's go back to VSB Plus page. So we log as can log as a student. So this is our first page about basic information about the student. So it shows basic information like major, GPA or credit, how many credit you learned. Also have one diagram on the right side. It shows the performance overall performance. And at the bottom diagram, it shows the performance on each semesters. That's the first page, and
In the default page, it displays the percentage of the student completion in their study. For the default schedule section, it will fetch the different JSON file based on the student major to upload the courses to take in each term or semester, which is the schedule that is provided by the university. And when the student has completed the courses, it will be filled up with the color. You can also click on the short name to output the more information of the course. And at the side section, it will lay out the elective courses to take. It will also show all the courses available in the university. Now we will move on to the customized pages.
This academic schedule builder page is intended to help the student plan their course for the future. So it is not precise, but the student can use it to plan how the future course plan is going on. For example, some courses like ENSE 380, this is only one term is applied. So it means if a student did not choose this course on the following semesters, it means they need to wait a year for the next chance. Tips are help the user to know how to build schedule and what are those indicators means. For the demo, the credits you can see is 42 here. If I'm going to choose ENSE 387, I want to choose it here for future. You can see the prerequisite is not matched. We need 352 and 384. Also, the term info is matched is go red. We can move to winter. Now the term info match, but prerequisite not match. So we can't find some courses like we want 352 here. We must put it 4 and have a pre-request CS210. Let's find out CS210. CS2 here, not CS2 match. It's okay to go. We still need 384. 384, yeah, so needs 282, 282, 282. Here it is. Oh, we can rematch this one. Let's all go black. That means it works. If for community of a student, if they forgot what they taken, they can check it here. For this one, we can see if I need to 387 means I have to take all those courses. So if I don't take one of them, means I need to wait another winter. I mean, here is a year wait to take this course. So like I can see the credit is added here. Now this is the page. Now it goes to semester schedule builder.
The purpose of this semester schedule builder is to help students manage current and upcoming semester courses. Through this page, students should be able to visualize the information of the selected course. The first thing to do is to choose the semester to be managed. Users can only choose between the current and upcoming semesters. Users can choose from two course registration methods. The first method is that user can register for courses by searching. The input field is not case sensitive, and it can also auto-complete the input text. The user can enter the course abbreviation or the full name of the course to search. After submitting the course name, if the student can register for the course this semester, the course registration message box will be displayed in green. Conversely, if the student is unable to register for the course this semester, the course registration failure message will be displayed in red. Then a warning message box will pop up to let the user know why the course cannot be registered. The user can also drag the text of the recommended course generated by the recommendation algorithm. After dragging the course tag, a drag and drop area will pop up to get the user to place the course to register for the course. If the user releases the course tag outside the zone, nothing will happen. To deselect a course, the user simply drags the text from the course list and releases it to the trash can. For the convenience of the users, the completed courses will be displayed in lower left. Users can get a general understanding of this course through the course description card. Users can also switch between different sections of the course. The weekly schedule builder will help users visualize the time of each selected course, including lectures and laboratory. This page also collects the final exam date for each registered course to save users time. If two exams are taken within 24 hours, the newly selected course will be highlighted. The scope icon of the course card is a link to the visual database for more information about this course. This is the architecture design of our website. Basically, it can be divided into three parts: front-end, back-end, and integrated open source. All front-end and back-end data are stored in AWS EC2 instance. Our website consists of 5 main functions, which will be introduced later. The GitHub code repository is connected with the server instance via a Jenkins pipeline. The data stored in the MariaDB can be quickly managed through phpMyAdmin. There are 3 open source APIs integrated into this project. So what is AWS EC2? It stands for Amazon Elastic Computed Cloud, which provides scalable computing capacity in the Amazon Web Services Cloud. And why did we choose AWS EC2? The first reason is that it is extendable. We can easily change the instance type to achieve faster computing or greater storage, and changing the instance type will not damage any lines of code. The second reason is that we have development experience based on it. Compared with other server providers, we are more familiar with it. The last reason is the most important reason, that is the economic reason. Compared with the Less-Sale or other server providers, AWS EC2 is cheaper. Our website contains 5 main functions. Users should be able to view their academic status graphically, including GPA or the user's academic performance. Users should be able to view the official academic schedule provided by the university and check their academic progress. In addition, users can customize their own academic schedule to increase flexibility. Users can also customize their semester schedule for current and upcoming semesters. For the convenience of the users, course filtering and search functions are provided.
We use the 3 open source code to help us to build the web pages. The first one is the full calendar, which is displaying the course time on the web calendar. The second one is chart.js. It helps to visualize the course data with the graphs. And the last one is the sync.php, which is a web development framework. Full calendar is an open source JavaScript API. We use it because it is powerful and easy to use. We only needed to set the necessary parameters for the calendar object. Then the calendar will appearing on a specific HTML element. And chart.js is an open source JavaScript library that uses the canvas element of the HTML5 to show the graphs and the charts. We just need to call the function with a parameter about the course data. Then the diagram will display on the web page through the canvas element. Sync.php is a simple PHP development web framework we use to quickly develop a admin management system just in 2 weeks. Because when we realized that we had to do an admin management system. It was close to the end of the project, but we complete the system before the due date.
Introduced to our backend setup, there are 5 components including version control, pipeline, data fetching, data storage, and database management. Next. Firstly, we choose GitHub to manage our code and document, and also it is very convenient for us to collaborate during the COVID-19 period. Moreover, the powerful Kanban board can classify our work by person, priority, backend, and frontend. Next page. Secondly, in order to collaborate with each team member, we install Jenkins on our server, so we do not need to worry about update the code on the server because we can just simply push our code to GitHub and Jenkins can help us update the code in server. Thirdly, due to our lack of data support, we have to crawl data from the university's website, then store it as a JSON file so we can use it on our database. We choose Python just because it is the best way to deal with data. Next. Fourthly, MariaDB is a free, open source, and powerful MySQL relational database, and we are all familiar with it. Next. The last point for the convenience of manage our database with the graphic user interface, we install PHP which is free and open source. Next. Our development progress is following this order: front end, server, collect data, and the backend. Next. For the front-end work, we did not use a framework, just simple HTML, CSS, and JavaScript, and also 2 third-party components. Next.
Setting up an AWS EC2 instance includes 3 steps. The first is to choose the appropriate instance type as the stored, because the better the performance, the higher the price. The second step is to install MariaDB and PHP for database management. And the last step is to install Jenkins in the server and start the pipeline to connect the server with the GitHub repository.
For the course data collection, we use Python to fetch the relevant course data. First, using the request library to get the HTML file, and then applying the Beautiful Soup library to select the relevant element and match the course details through the regular expression. Finally, we export the data in JSON format, and this is how we get the course data. For the backend development, we set up the database configuration and ensure that we can reuse it to connect other database. Moreover, we put the course per request check on the backend. We first convert the per request characters into other expression that can be recognized by the computers, and comparing them with the list of the course that the student have complete. For the course recommendation part, filter the course list that satisfies the per request and sorting them with a priority. Then recommend the top 10 class in the list.
And for the development cycle of this project, we see that the project definition and requirements cannot be skipped or complete in a hurry, as we have run into some trouble of finding the functional weaknesses and the defining of functional priority. If we can spend more time thinking carefully, the writing of code process may be faster instead of wasting time on feature addition and refactoring, and may also have a better understanding of the project to have a better interface design. We also have learned many compromises in the software development cycle. However, due to the limit time, we give up some function to complete the project on time. If we have more time, we can definitely design a better and more user-friendly interface. Lastly, we have learned and practiced the skill and technique that include but not limited to Python data parsing, Jenkins open source citation, HTTP, MySQL, GitHub, AWS EC2, full calendar, charge.js, etc. And this is the end of our final presentation. Thank you.